Welcome to lecture 6 of web-based technologies and multimedia applications. Today's topic for discussion is web servers. In the last session, we have seen what is meant by a client, what is a server, what is the role played by the servers in fulfilling the requests of the clients. There may be multiple servers. One request may be processed by more than one server, and the reason for having a high capacity servers and in what way servers should be reliable, scalable and secure so that the information sought by the client can be provided by the servers in real time without much delay. We have also taken some examples of why servers go down, why servers could not really provide information in some instances as per the client's requests. Now we have several brands of web servers. For example, Microsoft is offering a web server, then Apache is also offering a web server, and there are large number of companies which are providing us the web servers. Today we will see what is a web server and about these particular types of web servers that are offered by different companies. The objective of today's lecture is to introduce the concept of web servers. A server processes the request made by clients. Now you extend the client server domain on the internet application www, which is World Wide Web. Now you can clearly identify that you can make a request for a web page from the server. This implies that you are a web client and the server from which you make a request is a web server. As a web client, you just need to run an application program called a browser, whereas the web server is software that fulfills the request of web clients. A web server normally has a high-end computer with web server software. Some of the popular web server softwares are Apache servers by Apache Software Foundation, Internet Information Server by Microsoft, Jinx, that is NGINX web server by NGINX, Google web server by Google, Lightspeed web server by Lightspeed Technologies. These are some of the popular web servers. Of course, there are large number of companies that provide the services of a web server. A web server is also having a very good internet connection speed so that it can support multiple simultaneous users. It is also having its own domain and IP address. But how does this information exchange between the web client and web server is achieved? This whole communication is managed by a protocol called the Hypertext Transfer Protocol. However, the only protocol that works on internet, as we discussed earlier, was TCP/IP. TCP/IP, as already discussed, stands for Transmission Control Protocol or Internet Protocol. So what is this HTTP? Please note, HTTP can work only over a connection that is managed by TCP. Thus, it is a higher level protocol that uses the services of TCP. HTTP specifies the list of actions that lead to transfer of a requested information exchange between a web client and a web server. You must have already observed that whenever you type a website address, you start with HTTP or HTTPS. So HTTP:// the address is typed. Similarly, HTTPS:// the address is typed. The difference between HTTP and HTTPS is that in the cases of HTTPS, it is a secure hypertext transfer protocol. Whenever you wish to visit a web page on the internet, you request that page from a web server. When you type a URL into your browser, for example, http://www.ignou.ac.in, your web browser will request the page named index.html of this particular address from the web server, and the web server sends the page back to the web browser. Then there are different steps of communication that take place between the web browser and the web server. It is not that the client is requesting and the server is providing information. Yes, at the top level, that is what is helping ultimately. but there is a lot of exchange of information between the client and server, and a lot of things are in action, protocols and other things are in action, and ultimately the server provides information and the client requests it. But however, from the user perspective, for us, we just typed the enter button after typing the address in the browser and we got the requisite information, but a lot of things will be happening in between. As a first step, we may put a URL like http://www.ignou.ac.in/index.html or equivalent domain name www.ignou.ac.in as the address of the website that we want to access through our web browser. The web browser tries to resolve the IP address of the website by the information available in its own cache memory. If web server does not have the information about the IP address stored in its cache, it requests the IP address from the domain name system servers. The DNS server tells the browser about the IP address of the website. Once the web browser knows the IP address of the website, it then requests the web page, index.html page, which is the home page, from the web server. The web server responds by sending back the requested web page. If the requested page does not exist, then it will send back the appropriate error message. So one very important thing is that ultimately you need the IP address of the website. In case it is known, it's well and good. Otherwise also it has to be fetched and it needs to be provided for further communication to take place. Your web browser receives the page from the web server and displays it as per the display requirements of the web page. A web server is server software or hardware dedicated to running this software that can satisfy client requests on the World Wide Web. A web server can in general contain one or more websites. A web server processes incoming network requests over HTTP and several other related protocols. The primary function of a web server is to store, process and deliver web pages to clients. The communication between client and server takes place using the HTTP. A user agent, commonly a web browser or web crawler, initiates communication by making a request for a specific resource using HTTP, and the server responds with the content of that resource or an error message if unable to do so. The resource is typically a real file on the server's secondary storage, but this is not necessarily the case and depends on how the web server is implemented. While the major function is to serve content, a full implementation of hypertext transfer protocol also includes ways of receiving content from clients, and this feature is used for submitting web forms, including uploading of files. Many generic web servers also support server-side scripting using active server pages, hypertext preprocessor such as PHP, Java server pages or other scripting languages. This means that the behavior of the web server can be scripted in separate files, while the actual server software remains unchanged. Usually, this function is used to generate HTML documents dynamically on the fly as opposed to returning static documents. The former is primarily used for retrieving or modifying information from databases. The latter is typically much faster and more easily cached but cannot deliver dynamic content. Web servers can frequently be found embedded in devices such as printers, routers, webcams, and serving only a local network. The web server may then be used as part of a system for monitoring or administering the device in question. This usually means that no additional software has to be installed on the client computer, since only a web browser is required, which now is included with most operating systems. Let's go through a bit of history now. In March 1989, Sir Tim Berners-Lee proposed a new project to his employer CERN with the goal of easing the exchange of information between scientists by using a hypertext system. The project resulted in Berners-Lee writing two programs in 1990, a web browser called World Wide Web, the world's first web server, later known as CERN HTTPD, which ran on NextStep, that is NEXTSTEP. Between 1991 and 1994, the simplicity and effectiveness of earlier technologies used to surf and exchange data through the World Wide Web helped to port them to many different operating systems and spread their use among scientific organizations and universities and subsequently to the industry. In 1994, Berners-Lee decided to constitute the World Wide Web Consortium, which is W3C, to regulate the further development of the many technologies involved, HTTP, HTML and others, for example, through a standardization process. Web servers are able to map the path component of a uniform resource locator, which we call URL, into a local file system resource for static requests, an internal or external program name for dynamic requests. For a static request, the URL path specified by the client is relative to the web server's root directory. Consider the URL, for example, www.abc.com/path/file.html as would be requested by a client over HTTP. The client's user agent will translate it into a connection to www.abc.com with the following HTTP request: get path file.html HTTP to host www.abc.com. The web server on the www.abc.com will append the given path to the path of its root directory, and on an Apache server this is commonly /home/www. On Unix machines usually it is /var/www. The result is the local file system resource, which is /home/www/path/file.html. The web server then reads the file if it exists and sends a response to the client's web browser. The response will describe the content of the file and contain the file itself, or an error message will return saying that the file does not exist or is unavailable. Now let us discuss about kernel mode and user mode web servers. A web server can be either incorporated into the OS kernel or in user space like other regular applications. Web servers that run in user mode have to ask the system for permission to use more memory or more CPU resources. Not only do these requests to the kernel take time, but they are not always satisfied because the system reserves resources for its own usage and has the responsibility to share hardware resources with all the other running applications. Executing in user mode can also mean useless buffer copies, which are another limitation for user mode web servers. Now let us discuss about load limits on web servers. A web server, which is also a program, has defined load limits because it can handle only a limited number of concurrent client connections, usually between 2 and 80,000, and by default between 500 and 1000 per IP address and TCP port, and it can serve only a certain maximum number of requests per second, also known as queries per second, depending on its own settings. The HTTP request type, whether the content is static or dynamic, whether the content is cached, and the hardware and software limitations of the underlying operating system of the computer on which the web server runs. When a web server is near to or over its limit, it becomes unresponsive. Now let us have a look at the causes of overload. At any time, web servers can be overloaded due to excess legitimate web traffic. Thousands or even millions of clients connecting to the website in a short interval, which is known as /dot effect. Distributed denial of service attacks, such as DOS attack, can take place, and it is an attempt to make a computer or network resource unavailable to its intended users. Computer worms that sometimes cause abnormal traffic because of millions of infected computers that are not coordinated among themselves. Then we have cross-site scripting worms, which is nothing but a cross-site scripting virus which can cause high traffic because of millions of infected browsers or web servers. Internet boats traffic which is not filtered, limited on large websites with very few resources such as bandwidth and other things. Internet slowdowns due to whom client requests are served more slowly and the number of connections increases so much that server limits are reached. Web servers partial unavailability. This can happen because of required or urgent maintenance or upgrade, hardware or software failures. For example, of the backend database failure, and in these cases the remaining web servers get too much traffic and become overloaded. Now let's have a look at symptoms of a overloaded web server. For example, requests are served with possibly long delays, and sometimes the web server returns a HTTP error code such as 500, 502, 503, 504, 408 or even 404, which is very common and which is inappropriate for an overload condition. The web server refuses or resets interrupts due to which TCP connections could not be completely executed before they return any content. In very rare cases, the web server returns only a part of the requested content. So this behavior can be considered a bug even if it usually arises as a symptom of overload. Now let us have a look at some techniques which will overcome the load limits of a web server. One is managing network traffic by using firewalls to block unwanted traffic coming from bad IP sources or having bad patterns. HTTP traffic managers to drop, redirect or rewrite requests having bad HTTP patterns. Bandwidth management and traffic shaping in order to smooth down peaks in network usage. Deploying web cache techniques using different domain names or IP addresses to serve different content, both static and dynamic, by separate web servers. For example, images can be served, as well as another thing is that from the same website, apart from images, the text content can be served. Using different domains or computers to separate big files from small and medium sized files. The idea is to be able to fully catch small and medium sized files and to efficiently serve big or huge files by using different settings. Using many internet servers per computer, each one is bound to its own network card and IP address. Using many internet servers that are grouped together behind a load balancer so that they act or are seen as one big web server. Adding more hardware resources such as RAM disks to each computer is one way, and other is that tuning operating system parameters for hardware capabilities and usage is another way. Of course, these all are different ways to increase the efficiency. Using more efficient computer programs for web servers, using other workarounds, especially if dynamic content is involved. Now let us see the market share of various web servers. For example, Netcraft is a company that has done a survey in June 2020. They received responses from more than 122 crore websites, and they are residing on more than 26 crore unique domains and more than 1 crore web facing computers. So Nginx servers, that is Nginx servers, host nearly 45 crore sites. It's more than 36% market share. Apache web servers host nearly 31 crore sites. It's nearly 25% market share. Microsoft IIS hosts nearly 14 crore sites. It's more than 11% market share. Google servers host nearly 5 crore sites. It's nearly 4% market share. So the most popular web servers are NGINX, Apache, Microsoft, IIS. So these are the top servers that are used in the market. Then there are also other servers that are used. Most of us will be using IIS in our institutions long back, but as on date we do not know, like every institution must be using its own server. But however, the market share is very clear. NGINX is taking the top position, then we have Apache, then we have Microsoft IIS. So we can say that in the world, servers are normally from NGINX, Apache and Microsoft. So these are the different web servers that are being used. So what we have to do is that what are the unique features of each of these servers? That is very much important. For example, you want to have a server. Which server you should go for? Should you go for Microsoft? Should you go for Apache? Or should you go for NGINX? Or should you go for a Google server? So for that, what you have to do is that you have to find out the results of surveys, like what are the advantages of an Apache web server, what are the advantages of a Microsoft web server, what are the advantages of a Google server, or what are the advantages of a NGINX server. So based on your requirements, you have to zero in on one of these servers, and one most important factor is cost. What costs more and what costs less? So we need to work on an optimized server selection. That is, the cost is appropriate, the support is appropriate and fulfills our requirements. So keeping these things in view, we will be ultimately zeroing in on one of these servers. So Netcraft is the company which has done this particular survey. One important thing is that the website is https://www.netcraft.com. When you go to this particular website, not only the market share of the servers of June 2020, you can also find historical data. Historical data is very useful because suppose the market share of a particular server is increasing, you need to find out really why it is increasing. If something is decreasing, you should find why it is decreasing. Suppose that you are using a server whose market share is decreasing, then you should really research. If at all you switch from your current server to the server that is catching up, then is there any chance of increasing the business of your domain? So it makes really business sense that you go to this website, you find the market shares of various servers, and then ultimately you take a call which is better, and then by that particular server or host your data on that server or applications on that server, so that you get complete support of the transactions which you commit. Apart from Netcraft, there are many other companies also that does this. But when I have gone through the web, I found that this particular site is giving information in such a way that it can be easily interpreted, and it is having the latest data which is June 2020 as well as the historical data. So when we consider all the data, definitely we will be finding that why market share is increasing and decreasing, and it has something definitely to do with the technicals also. So one is underlying technology, the second is cost. So you have to work on both these factors and see why anything is increasing their market share and why something is decreasing its market share, and accordingly the decision needs to be taken. So in today's discussion, we have seen what is a web server, what are the different types of web servers, what is the support we expect from the web servers, and why web servers are very much important in running the internet in a smooth manner. I thank you all for attending the today's presentation, and in case you have any doubts or questions, please feel free to drop an email to me. Thanks a lot.